is Michał Witek, and I'm a senior front-end developer at CodiLime. Throughout my career, I have frequently experienced the process of refactoring, whenever it involves switching to new libraries, transitioning to different frameworks, or modifying code patterns. It is a daily occurrence. In this context, I would like to demonstrate how we can enhance this process by utilizing artificial intelligence, specifically in the realm of refactoring end-to-end tests. As an introduction, I will reveal the use case and shed light on the refactoring process itself. Following that, I will present the results of my research into large language models, LLMs, and highlight the importance of prompt engineering. Next, I will share the results of my research and development. In this section, I will demonstrate the example application and its end-to-end test codebase written in Cypress. After that, guide you through the test migration process to Playwright, which is definitely the most crucial part. Finally, I will wrap up with some concluding thoughts in the form of summary. Refactoring is the process of restructuring existing computer code without changing its external behavior. It involves adapting and improving existing code bases to leverage new technologies, frameworks, or libraries without altering the fundamental functionality of the software. This process is crucial for maintaining the relevance, performance, and security of applications as the technological landscape evolves. In other words, we need refactoring to keep our software safe, healthy, and up to date. It is also a good practice to have space for refactoring as a constant process in software development. Refactoring can be a challenging and complex process with variations in scope, technological requirements, limitations, and more. Transitioning from one framework to another may be tricky, as it typically involves refactoring piece by piece while keeping both the old and the new parts operational at the same time. Nonetheless, such refactoring is sometimes necessary, especially when a technology becomes obsolete or when the technological debt is so overwhelming that rewriting in a new technology is more practical than maintaining the old. I will focus on migrating the end-to-end test layer from Cypress to Playwright with the support of artificial intelligence to boost the process. However, the method that I use can be applied to many other transitions as well. Before we dive into the case presentation, let's cover some basics about AI and large language models. LLMs are capable of understanding and generating human-like text, and since programming languages are also forms of a language, LLMs can comprehend and operate on them as well. LLMs are great at translating one language to another, and this feature is what I will leverage on to translate Cypress codebase to a Playwright codebase. For more information about LLMs, please refer to the link in the description where my colleague Kasia provides much more details on the topic. Getting to the point, I needed to determine which model best suits my purposes, and the ranking is the result of this research. For my case, DeepSeek Coder version 2 was the best, although OpenAPI GPT-4 Turbo and regular DeepSeek V2 were also strong contenders. I base my ranking on errors shown by development environment, both logical and syntax bugs, and the time required to get the refactored test case working properly. It's important to note that the models are constantly updated and trained on different data, as well as LLMs are non-deterministic in general. As a result, the outcome at the time of this presentation might differ from the outcome when you are watching this video. If you're considering a similar use case, DeepSeek Coder version 2 may be a solution for you, as well as a different model might work better. I will conclude this case with famous "it depends." Now I will show you the application and give you a quick journey about the features, because it's essential in context of the end-to-end tests. Link to the codebase is in the video description. This is a React and Node application with Mobic state management. To run the app, I need to start the frontend as well as the backend, and we're good to go. So to start the backend, I need to type npm run backend. Okay, it's working. And now start the frontend with npm run dev. So just like a React app. And the browser window appears with the dashboard page. So basically the application has 4 pages: the counter, movies, users, and dashboard. And I will start from the counter page. So it's exactly as it looks like. It's a simple counter that displays the value on the button click. Nothing fancy here. Negative values always supported. The next feature, it's the movies page. So this contains of a search input and a list of movies. If there is nothing in the search input, all the list that is processed by backend is sent to the frontend and displayed. However, if I type something, for example, Mary Poppins or just Mary, the results that match the input value appear. The same for Titanic. This is, but if I type something like M, which matches more than one case, then of course more results are presented. Okay, let's go to the users page. So here you may see an implementation of a quite standard CRUD, so create, read, update and delete operations that you can perform. I can check multiple users, delete, refresh them. I can add a new user. I can edit the existing user if I need to. And of course the whole page is paginated. After that, that is the main page, getting back to it, the dashboard page, which consists basically two charts. But the thing that is interesting here, when I click the go button or the play button, then the data will be updated. Yes, because the data pooling starts. So what happens on the backend side, we have standard data pooling in time intervals. So there is a request made to the backend for the new data backend provides, and those data are rendered on the frontend. Every feature has its end-to-end test file, which covers the functionalities. However, before we dive into details, I will show you how to run tests in general. To trigger the test run, I need to type npx cypress run, and this will execute the test case headless. However, there is also an option to run the test with visual mode, and this is the thing that I'm going to use now. So to do this, I need to type npx cypress open, then choose the end-to-end testing. This is already configured. Choose the browser against which I'm going to test, and I got the interface. Okay, so in this interface you can see all the test files that are recognized by Cypress, and for each of my pages there is a separate one. All the test files recognized by Cypress are listed in this interface. When I click in any of those, like for example the counter one, a specific test suite will be executed with a detailed report. As you can see, the test visits a specific page, then clicks up the button and checks if the value displayed is the expected one. The same once again, and a similar test is executed for the down button as well. Okay, this is how it looks like in the code. This is a Cypress command. Cypress command is a similar concept to a function. It just makes repeatable actions reusable. I will show this in a second. And then you can see the test. So, get the proper button, click it, and check if the value is the expected one. And here are the comments. So basically comments are used often for visiting pages, or for example clicking more complex HTML elements on the page. Getting back to the movies, the test for this page is a bit larger, because the page elements are needed to be tested if they are visible or not. Also, the interaction is a bit different because input field is provided with a value, and based on that value the list is checked. Okay, here it is. It executes well, and here is the code. So basically, as you can see, there are a lot of elements that need to be tested, but the whole else interaction is to provide the proper input value and then check based on that input value if we are getting the correct values on the list. Now the dashboard. Complexity increases here. This is because backend interactions happened. So the test checks the loading state, then simulates what happens on the error and checks what happens on the success. And then on the success case, if the expected API calls were made with checking the specific API call properties. So this is how it looks like in the code. So the test is not very long. However, it checks the loading state, it simulates the error code, and then checks if the specific API call has specific metric, in this case, as a property. The most complex test suite is for the users page. This is because all of the CRUD operations are tested, the loading state is tested, and the error state is tested as well. Besides that, some deeply nested elements are checked, and this is how the test runs. Okay, so loading state. Now there is a lot happening in the preview. Okay, editing of the user. And finally the user deletion. Okay, everything went smoothly. And this is how the test looks like. So first of all, I have some example data. This is for adding and deleting, and also editing. Then the test checks the loading state, simulates an error state, renders the users list, the initial list, then adds a new user and checks if the new user was added correctly. After that, the edit operation, and finally the deletion operation, which has a quite tricky thing that needs to be selected. So this is the checkbox with the proper email in this case. And that's all. Now let's finally proceed to the migration process. I have already installed Playwright and did the configuration. This is quite easy and is usually a one-time thing. I also prepared the empty files for the new test cases code. Let's start from the easiest one, so from the counter. This is the DeepSeek Coder v2 communication window that I'm going to use for my prompt engineering. So first of all, the general structure of the prompt. It will include the Cypress command code, the Cypress test code, obviously, and then the instruction what the LLM needs to do. So first of all, refactor Cypress code into Playwright code. This is obvious in our case. Then return only TypeScript code. This is also required because otherwise I would probably get a JavaScript code, which is not really working for me at the moment. Then a trick that really works well with the LLMs and no one knows why. Be as less creative as you can. Focus on the accuracy. So we're doing programming, so accuracy is really required. And now let's fulfill this prompt with data. Okay, so this is the command code. Now the test code. And send. Let's see the results. So those results are quite promising. However, I would like to modify one more thing. I'm not a fan of the page locator. I would like to have something else instead. So the thing that I'm going to do, I will copy the previous prompt, all of this. I will clear the context, copy this again, and add another instruction here. And this would be use page get by text and page get by role instead of page locator. And let's go one more time. Okay, I've got my end results. Now let's paste it to the project. Exactly the same prompt worked well for the movies test suite as well. This is the result of refactoring process. As you can see, the test visits the page, modifies the search input value, and then checks the result. To check if this is 100% working correctly, I will now start Playwright and check for both counter and movies tests. Okay, to start Playwright, I need to hit npm run test playwright UI. This is a command defined in my package.json. And I have the Playwright interface. I can run each test separately, but I will run all of them at once. Okay, everything is green. If I go deeper here, then I may check what the test really does. So in fact, every command is testable, and also there is a preview what was happening on the screen, which is quite useful, especially in development and debugging. The same for movies. There is much more here, but every operation is checkable here. The two remaining test cases I want to refactor are more complex. Primary, because they also involve testing the network layer. The prompt that worked well for the previous cases isn't sufficient here. It requires more detailed specifications. Additionally, I need to clarify that the Cypress tests were conducted using the real API responses, not mock data, and I aim to achieve a similar setup in Playwright. The only exception is the error test case, where an API call needs to be intercepted and modified to similar a failure. Here's how the new prompt structure will look like. As you can see, exactly here, it includes additional information for handling network interactions. Working with LLMs is quite unique, so I can't precisely explain why this approach works, but in my experience, trial and error method works best. Now let's fulfill this prompt with real data. So starting from Cypress commands, and now the Cypress test case. Okay, and send. Now DeepSeek is producing the results. Let's wait for it. Looks quite promising. However, let's try this. Okay, the spec file. Okay, still looks promising. Let's save this and let's try this. Okay, the Playwright interface, and let's execute the dashboard tests. Okay, so far so good. I will execute exactly the same command once more and try to force the model to hallucinate. Oh, and here it is. The problem is exactly in this line here with the route. The parameters here are not correct. I will show you. Let's replace the working test with the not working one. And as you can see, this get shouldn't be here. The URL should be the first parameter. So this is the risk of using LLMs. They sometimes hallucinate and do not provide the results that we really want. However, as you've seen in the previous attempt, the results were perfect. And finally, the user's test. So the most complex one, definitely, in this example case. So I will start with the prompt and show you what was modified here. So For every page get text, add exact true as an option. I will present it a bit later why this is needed. And one cosmetical thing, use fill instead of type, and also use fill instead of clear and type. Now I'll get back to the tests. Do the exact same process. So the commands, the users test, it was copied and sent. So DeepSeek needs some time to process this. Yes, you can already see that the exact true is placed properly here in getByText, and basically it is needed because with this parameter false, Playwright would find two elements, the John and John Doe email. So basically this element and this element. Also there would be exactly the same problem with the last name. So Doe without the exact true would also find the last name and the email. And okay, it's still thinking. And let's see the results. I'm going to copy this and place it in the test file. Okay, no errors so far. And let's see the usage. Okay. I already have the user's test here, so case by case. First one is correct. Second one works well. So far so good. Add new user. Also correct. Edit user. Also fine. And finally delete the user. It's thinking, so it's a bad sign. Let's give him a few seconds more. And an error case. In a second I will explain why this happens. Let's get back to the exact true flag. Okay, I will scroll down to the should render users list and change the exact true to false for John. Okay, now I will execute the test, only this one specific, and see what happens. Okay, we got an error, and this happened because two John elements were found on the page. And this is exactly the reason why this flag needs to be set to true for the getByText selection. Now I will switch back to true, execute the test one more time, and now it is clean and green. Let's investigate the user deletion test. So this one that is failing right now after the refactor process. So to do this, I will go back to Cypress tests, and yeah, this is the exact line that is causing the problem. So a very complex element selection. So double parent searching, the data ID that is not the usual end-to-end test data ID, but some other data ID. And this is something that Playwright wasn't able to convert properly. Yeah, let's try to find. Here is the attempt of this, and this is the checkbox that wasn't clicked properly to fulfill the test. And I would consider this an edge case and not prompt engineer more to resolve this, because the root issue is this line. This in fact should be resolved in a better manner, and then also the refactoring process would go smoothly. I'd like to highlight the prompt used for the final test cases. It meets most of my expectations, except for one edge case that arose due to low quality Cypress code. However, if you choose to use this specific approach, you may need to customize the prompt to suit your specific needs. In general, I recommend not overthinking prompt engineering. If something doesn't work, try rephrasing or experimenting with different commands instead of analyzing why a specific one didn't work. Additionally, many LLM models tend to respond better to positive commands like use rather than negative ones like avoid, never, or even don't use. In conclusion, despite some edge case errors, I truly see the value of LLM support for code refactoring. Even in the test example, for 4 features, I was able to complete the task more effectively than if I had written everything manually. This approach is especially useful when dealing with a large test codebase. However, there are a few additional considerations. For large files, there's a risk of exceeding the model's context limit, so it might be necessary to split test files into smaller ones. When handling a large number of files, it may be more efficient to write a script and use an LLM model API for file conversion rather than relying on the chat interface. Finally, for sensitive code, consider using a local LLM model instead of a cloud-based one to ensure everything stays within your network. I hope you found this video helpful and that the techniques presented here will save you some time. Thank you for watching and stay tuned for more insight on AI technologies.